Hello and welcome back for lesson 3.5. We are going to look at tree and Venn diagrams. And a tree diagram is a special type of graph used to determine the outcomes of an experiment. It consists of branches that are labeled with either frequencies or probabilities. Let's look at the try it for 3.24. In a standard deck, there are 52 cards. 12 cards are face cards, event F, and 40 cards are not face cards, event N. Draw 2 cards one at a time with replacement. All possible outcomes are shown in the tree diagram as frequencies. Use the tree diagram, calculate probability of FF. Okay, so first of all, with replacement means that we're going to draw a card and then put it back. So there will still be 52 cards available for the second card. So on the first card, I'm just going to write card 1. We have 12 cards that are face cards. So 12 out of 52 are face. So we're going to write face and we're going to put 12 out of 52. And that is 0.2308. And then over here are the non-base cards. And that is 40 out of 52. And that comes out to be 0.7692. Okay, and then we put the card back and we get to draw again. So that was card 1. Now we have card 2. So card 2 happens, and because we did with replacement, they are independent. Okay. And so because they're independent, it is going to be able to multiply these at the end. So the second card has the same probability as the first card of face and no face. So the face card is going to still be 0.2308 and the no face is still going to be 0.7692. And then over here, if we got a card that was not a face card on the first card, but the second card could be a face card, the likelihood is 0.2308, and the probability of a non-face card is 0.7692. Okay, and then our overall probabilities would be the probability of a face and a face is right here. Face and face, that's our actual outcome. And because they're independent, we can multiply them together, which is equal to 0.2308 times 0.2308. Which is 0.0533. So part of it is learning how to draw the possible outcomes and calculating the frequencies. All possible outcomes are shown in the tree diagram as frequencies. I'm counting them as their actual probability. So this probability and this probability. So let's look at the next try it. Okay, so we are going to look at 3.25. So we still have the same similar situation, 52 cards, 12 cards are face cards, 40 are not face cards. Draw 2 cards one at a time, but this time it's without replacement. Okay, so we draw a card and that card does not go back in. So the tree diagram is labeled with all possibilities. So let's go ahead and look at this one. So here it is. So we have face card is 12 out of 52, not face card is 40 out of 52. But once you draw, if you draw a face card on the first card, you now only have 51 cards. Okay. If you draw a face card on the first card, you only have 11 face cards left to draw from, but you still have the 40 non-face cards. And so getting a face card and a face card is 12 times 11 over 52 over 51. If you drew a face card and then not a face card, you're going to do 12 times 40 over 52 times 51. The third option is you drew a non-face card on the first card. That means the second card could be a face card, which you still have 12 of, or your second card could be a non-face card, which you only have 39 remaining. And then you're going to multiply them to find the end result. So you could have face card, and then a non-face card, and then a face card, or two non-face cards. So A says find the probability of face card, non-face card, or non-face card, face card. So you cannot have them both. So we can add their probabilities together. So this is 480 plus 480 over 2652, which is 960 over 2652. Which is 0.362. We'll round it to because of the 9. Okay. Then it says find the probability of not getting a face card given that you had a face card first. So given that you had a face card first, the probability of not getting a face card is 40 out of 51. Okay. Find the probability at most one face card. Hint, at most one face card means 0 or 1. So the probability of 0 face plus the probability of 1 face means 0 face cards would be NN. So 1560 plus 1 face card would be these two, 480 plus 480. So 480 plus 480 all over 2652. Which comes out to be 0.9502. Now, you could say at most one face card means you could subtract away when you got 2 face cards. That's the only one we're not including. So we could say 1 minus this right here where we had 2 face cards. And that is 0.0498. So we could say 1 minus 0.00498. And we get 0.9502, exactly what we had before. So that's using the complement rule. 2 ways to do C. So D says find at least 1 face card. Oops. Hint, at least 1 face card means 1 or 2 face cards. So at least 1 face card means at least 1 or 2 face cards. So that would be these two again, 1 face card or 2 face cards. Or we could say 1 minus the probability of no face cards, which would be 1 minus the probability of no face, which is 1 minus 1560 over 2652, which is 1 minus 0.5882, which is 0.4118. So that is all for the tree diagrams. Now I would like you to, I don't have these printed out, so you should possibly have these printed out. So let's go back to our notes here and let's look at the Venn diagrams. A Venn diagram is a picture that represents the outcomes of an experiment. It generally consists of a box that represents the sample space S together with circles or ovals. The circles or ovals represent events. Let's look, I'm going to show you a picture. So here. So this is what they look like. You have event C, and then you have event PT, and then if there are any overlapping in the sample space that are in both C and PT, they go inside here. So to draw these, it's a little bit tricky because you have to think about the outcomes first before you start drawing. So let's look at the try it for 3.27. It says, suppose an experiment has outcomes black, white, red, orange, yellow, green, blue, and purple, where each outcome has an equal chance of occurring. Let C be the green, blue, and purple. Event P be the red, yellow, blue. C and P is blue. C or P is going to be green, blue, purple, red, and yellow. Draw a Venn diagram. So we have I'm going to put the whole thing in a box. And then the sample space. So there are some that are not in any of our events. It looks like black and white and orange are not in any. So black, white, and orange are not in any. So let's just write out our sample space. So we've got black, white, red, orange, yellow, green, blue, and purple. And they should each be accounted for somewhere. So I'm going to show you my paper here. Oops. So there are all the possible outcomes. Okay. And so C is green, blue, and purple. So green, blue, and purple. Now it says blue is in both. So I'm going to do blue over here because it's going to be overlapping. So C has green and blue and purple. So green and purple are only in C because C has green, blue, and purple. And C and P have blue. P has red, yellow, and blue. So other than the blue, it also has red and yellow. And that's P. So every color up here should be represented. Black, white, and orange right here are not in either C or P. And then yellow is in P. Green is in C. Blue is in both. Purple is in C and red is in P. So that's how that would look. So they share blue because that's the and. Okay. So let's look at the next one. So try it 3.28 says roll a fair six-sided die. A is going to be a prime number of dots is rolled. And B is an odd number. So our sample space is 1 through 6 because it's a six-sided die. So let's just write the numbers 1, 2, 3, 4, 5, and 6 at the top. And then we're going to draw our box. A is 2, 3, and 5. B is 1, 3, and 5. A and B is 3 and 5. So we want to draw the circles and have an overlapping space and put the and, which is 3 and 5. So I'm going to share my paper so you can see. So notice I listed them all out. So 3 and 5, it says, are in both. So those are accounted for. And then it says 1, 2, 3, and 5 are in or A or B. So it looks like 4 and 6 are the only ones that are not in either. So 4 and 6 can be out here wherever you'd like them. So A is 2, 3, and 5. So this is A. And so 2 is the only thing that's not in the shared space. And then B is 1, 3, and 5. So 1 is the only thing not in the shared space. So let's just make sure they're all represented. 1, 2, 3, 4, 5, and 6. There they are. Okay. Let's look at the next one. The next one is 3.29. Probably just easier if I just share my book since it's right here. 50% of the workers at a factory work a second job. 25% have a spouse who also works. 5% work a second job and have a spouse who also works. Draw a Venn diagram showing the relationships. Let W works a second job and S's spouse also works. So how about we do, this is 3.29. And then our sample space is all people that work at the factory. So that's what our square, our rectangle here actually is represented by. Okay. And it says 50% of those people that work in the factory have a second job. And that is W, work a second job. So let's just draw that. So this is W. I'm not going to put numbers in them yet. 25% have a spouse who also works. And that is S. So I'm going to write up here some information. So 50% work. That means there's 50% in this circle, but that also means that there's 50% who don't work a second job. Right, that work at the factory, but they don't have a second job. Because everything has to add up to 100%. Then it says 25% also have a spouse who also works. Okay, and the shared space is the 5%. So that we know. So that's good. So of the 50% that work a second job, 5% is in the shared space. So that means this is 45%. They have to add to make the 50%. And then S is 25% of the total people have a spouse that works. So that means that the 5% that's shared, then there's 20% here. Hmm. 25% have a spouse who also works, 5%. So it looks like we have 45, 50, 70%. And so that means there must be 30% out here that don't work a second job or don't have a spouse that works, because our percentages all need to add up to 100. That one was a little bit trickier. Okay, so the last one I want to do is the try it for 3.30. So let's check it out here. So it says, in a bookstore, the probability that the customer buys a novel is 0.6. The probability that the customer buys a nonfiction book is 0.4. Suppose that the probability that the customer buys both is 0.2. Draw a Venn diagram representing the situation. Find the probability. Well, we can't find probabilities until we get the Venn diagram. So let's draw the Venn diagram first. So you should have it up on your screen or in your book. It's 3.30. So I like to draw, we've got circles that overlap. And we know that the novel is 0.6. I'm going to write that up here. Novel is 0.6. And the nonfiction is 0.4. Now that's not 100% of people, because it says, suppose that the probability that the customer buys both is 0.2. So that's the both is 0.2. So that means that the novel 0.6 minus 0.2 is 0.4. So these have to add to make all the novels. And then 0.4 minus 0.2 is 0.2. And these are the non-fiction people. And then I have to talk about everybody else. They didn't buy either, right? So that would be 1 minus 0.4 minus 0.2 minus 0.2. And so that would, whoops, 1 minus 0.4 minus 0.2 minus 0.2. I can't type today. That is a subtraction. Okay, so there's 0.2 that are out here that didn't buy either type of book. So let's look at question B. It says, find the probability that the customer buys either a novel or a nonfiction book. So B says probability novel or nonfiction. So or would be all three of these together. So that's 0.4 plus 0.2 plus 0.2 is 0.8. C says, in the Venn diagram, describe the overlapping area using a complete sentence. Okay, so we can turn that 0.2 into a percent. When we're describing in a sentence, we should talk about it as a percent. So we could say 20% of the customers purchased both a novel and a non-fiction book. Let me write this down. D says, suppose that some customers buy only compact discs. Draw an oval in your Venn diagram representing this event. And that would just be something over here, right? We'll call them CD. We don't know what percentage it is. It didn't tell us, but they would have this description. So there are two problems for 3.5 if you didn't catch it. Problem 116 right here and problem 125. They're listed in Canvas for you. So that is all of the content for exam 1.